Yellowstone volcano's unconformity, over 60 million years of missing geological history. This is by USGS. Visitors to Mammoth Hot Springs in Yellowstone National Park might have noticed an odd geological feature near the top of Mount Everest, an unconformity. This juxtaposition of different rocks serves as a marker of missing history in the Yellowstone region. This is dated June 14th, 2021 by Michael Pollan, scientist in charge of Yellowstone Volcano Observatory. Now, most visitors to Yellowstone are entranced by the spectacular thermal features and evidence of past volcanic eruptions that dot the landscape and that are a testament to the recent geologic activity of the region. But there are hundreds of millions of years of geological history preserved in the rocks of Yellowstone National Park, telling a story of shallow seas, ancient volcanoes that left behind petrified wood, and glaciers that covered the landscape. One of the more interesting features is preserved at the top of Mount Everest and tells a story of missing geological time, where ash from the 2.1 million year ago Huckleberry Ridge tuff lies directly on top of 65 million year old sandstone. And this is it right here. Michael Pollan's picture, Huckleberry Ridge, right on top of the sandstone. So what happened? Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. Mount Everest was named for Truman Everett, a member of the 1870 Washburn-Langford-Doane expedition to Yellowstone. He became separated from his companions, horse, and all his supplies, and spent 37 days wandering in the wilderness, subsisting mostly of the roots of a thistle, which now bears his name, before he was discovered by a search party. Mount Everest is composed of light-colored sediments that were deposited at the margins of a shallow sea that used to exist in the Yellowstone area. Yes, a shallow sea. The rocks are mostly shales and sandstone, and there are even some coal seams from plant matter that collected in coastal swamps. The environment might have looked a little like the Mississippi Delta does today. These sediments accumulated during the Cretaceous period, about 120 to 65 million years ago, but at the very top of the mountain, on its eastern side, is a red-brown layer that seems to cut at an angle across the grayish sediments. This rock is the Huckleberry Ridge tuff, which erupted from the Yellowstone system 2.1 million years ago. That was a super eruption, as we know. The contact between the sediments and the tuff is an angular unconformity, a boundary where one rock unit cuts across the layering of another. This indicates a period of erosion and a time when no new rocks were deposited. Essentially, about 60 million years of geologic history is missing from the rock record. The gap in geologic history occurred because of an episode of mountain building, which started in the Yellowstone area about 60 million years ago. This episode contorted, folded, tilted, faulted, and uplifted the existing sediments. As a result, no new sediments were deposited, and in fact, the growing mountains began to erode. The erosion continued unabated until the eruption of the Huckleberry Ridge tuff, the first major volcanic event of the Yellowstone system, and the first period in which rock was deposited in tens of millions of years. The tuff covered all the rocks of the region, including those of Mount Everest. Right at the unconformity, an ash fall deposit, which represents the opening stage of the Huckleberry Ridge caldera-forming eruption, sits right on top of the Cretaceous sediments. Atop the ash fall is a welded pyroclastic flow deposit that marks a major explosion of the Huckleberry Ridge eruption. The ash was very hot when it was emplaced oxidizing the soil below the ash and giving it an orange tint. And above the ash fall, at the base of the flow, there is a black layer caused by rapid chilling of the flow in the contact zone. These colored layers can be spotted by keen-eyed observers as far away as Mammoth Hot Springs. And in fact, Mammoth Hot Springs is the best place to view Mount Everett's unconformity. If you have a good fortune to be able to visit Yellowstone, take a stroll on the boardwalks of the hot springs terraces and look at the north on a sunny day. The unconformity will be on display, brilliantly illuminated. Unconformities are not unusual in the geologic record. Another famous unconformity is the so-called Great Unconformity, lies under the bottom of the Grand Canyon and indicates in places about 1 billion years of missing geologic time. Even though they represent gaps in geologic history, unconformities provide critical evidence of the geologic forces that have shaped a region. And that includes in Yellowstone, where relatively young volcanic rocks lie directly atop the deposits that formed along the coast of an ancient inland sea. So we have pictures of, on Mount Everett's, the shallow sea sedimentary rocks from the Cretaceous period are the overlain by the Huckleberry Ridge tuff volcanic deposits from the first caldera-forming eruption of the Yellowstone hotspot 2.1 million years ago. Please leave your comments and thank you for your support. This is by USGS Yellowstone Volcano Observatory Caldera Chronicles.